Okay, Caitlin, here we go for problem number 2. You were really close with this answer as well. You were just missing that last term of the 5 arctangent x. It does not involve the square root. That's the only thing you did wrong. But I'm going to go over the whole thing with you. Okay, so if I just look at the first term of 3, the natural log of 6x, what you want to think of is 3, the natural log of u, where u is equal to 6x, and du, sorry. I'm using a thin pin here so I can scrunch it all in. And du is equal to 6. So if I look at what the derivative is for that, if you remember, the derivative for the natural log of u is 1 over u. So you're going to get 3, 1 over u du. Now all you have to do is substitute in the information. So if you substitute in your information, it's going to be 3. U happens to be a value of 6x, and du is a value of 6. Then what you notice is your 6 is actually canceled, so you end up with 3 over x. And I think that's it. That's what you had on your answer. Okay, the next thing we want to look at is we want to look at this next term, which is 4u. If I look at that particular term, that's a constant. So the derivative, I know it's pi, but you had this right, I'm pretty sure. And the derivative of a constant is just going to be a 0. So that particular derivative is 0. So now let's look at the next term. So the next term is 7x to the 7.5. That is going to happen to be the power rule. So if I look at the power rule, that you're going to take 7, you're going to bring down the exponent, which is 0.75, and you're going to take the exponent of 0.75 and you're going to subtract 1 from it. So if you simplify that, this I noticed you didn't simplify it, and maybe you don't have to on your test that you're taking. You could leave it as 7 times 0.75, which is what you had. If you multiply that, you get 5.25, and then if you subtract that exponent, you get minus 0.25, or minus a fourth, or minus 25 hundredths. It depends on, I probably would have done it as a fraction, but anyway, that's what you end up with. And the last term that we have, I don't like that purple right next to it, so I'm going to change it over here to, let's make it this gray, because I think you could probably see that. Now I need to change the thickness of the line, but it's still there. Okay, so now if I look at this last term, which is the arctangent, one thing you have to remember here, we need to think of our thought bubble and say, what is the derivative of the arctangent? And the derivative of arctangent, let me write it. The derivative of arctangent is 1 over 1 plus x squared. So what I need to take the derivative of is, so then if I take the derivative with that 5 involved, my derivative is going to look like this. 5 times 1 over 1 plus x squared. So if I write my answer, I have the derivative of each term. Your answer is going to become 3 over x. I think that was a plus sign there. Plus 5.25, which you had 7 times 0.75, so you are close. X to the negative 0.25 plus 5 over 1 plus x squared. Now, from the results of your answer, I'm gathering that you don't have to simplify that anymore by coming up with a common denominator. So again, you are so close with your answer. The only part is, I believe, right here at that 1 plus x squared, you had the square root of that, which I think gets into the derivative of maybe like an arcsecant or something like that. I don't remember the arc derivatives very well, and I had to look this one up actually in the book. So I believe what you were doing was arcsecant or something, but that's the only spot is you have that square root there. That's the only spot I can see where you went wrong with your answer. So I hope this helps as well, and you're gaining confidence yet. I've only looked at 2 problems, and you were really close. There's only little errors with it. Keep going. You've got this, girl. I'm going to post another one. Here we go.